Hello everyone and welcome to the Interactive Factbook 2.0 Capstone project. Today we will be introducing you to the Factbook and covering what we've accomplished so far this term and what our overall project goals are. The contributors to the project this year were myself, Michael Ben, Elizabeth Blackwell, and Anthony Ungaro. Alright, for motivation, first off let me introduce you to our client for this project. It is SOU's own institutional research department with Jake Scott representing them. The IR department is on a mission to provide the campus and general public with timely, accurate, and insightful data via their annual Factbook. The SOU Factbook contains 50 pages of information about the general student body and staff, including enrollment, tuition rates, demographics, and graduation rates, etc. Traditionally, hard copies are distributed across campus, and electronic PDF versions are available online. Last year, Jake put together a capstone team to provide greater accessibility to the Factbook through a live web version. While the Factbook is fully functional, there are some opportunities for improvement, such as both Boca and Django had major releases just after last year's project concluded. Also, currently the Factbook is built such that each graph has a web page built around it, making some information that should have a second graph to better understand hard to convey. Furthermore, many of the graph's color schemes are not friendly for the visually impaired users. There is also not a way for a user to leave feedback unless they took it upon themselves to look at the contributors section of the homepage and try to email one of the contributors. And currently there is no automated process for updating the Factbook, which requires Jake to spend about 90 minutes a week in order to keep the Factbook updated. Our project goals are the following. Alright, so our major requirements and features. To reduce the amount of time spent maintaining the Factbook, we are implementing an automatic database update feature and increasing the database insertion performance. To ensure that new contributors can easily join the project, we have updated the code to utilize the newest versions of packages and created a wrapper class for building a line graph. And we will be implementing more wrapper classes in the future to fulfill this goal. To provide an accurate depiction of IR data and ensure that all users can fully utilize the Factbook, we will be correcting some graph ambiguity. As mentioned before, some graphs don't accurately convey the information they're meant to. As well, we will be implementing a feedback button so users can submit feedback directly to IR about the Factbook or request new information. And then to improve the website accessibility for the visually impaired, through screen reader testing and adjusting color scheme for easier readability for colorblind users. And lastly, to implement an IR data dashboard, which is a collection of graphs that IR currently uses that Anthony will be demonstrating in just a minute. For our technologies, the major technologies for this project are Boca, Django, and SQLite. There are 35 total dependencies the Factbook uses, but the rest are actually just to support these main three. And now Anthony will demonstrate what we've accomplished this term.
Thank you for the introduction, Michael. Hi guys, my name is Anthony, and today I'll be showing you a live demo of the Interactive Factbook 2.0. I'll be going over our test pages, which is where we acquainted ourselves with the current codebase. Once we were acquainted with the codebase, we were able to add functionality in the form of a wrapper class. A wrapper class encapsulates the Boca library functions, which streamlines the creation of graphs and makes it easier for newer developers to add to the project. Working forward from that, we were able to add in a data dashboard which encapsulates multiple graphs into one easily viewable image. For our test pages, we first had to acquaint ourselves with querying the database. Once we're able to query the database, we store the data in a Python dictionary. We then pass that dictionary to the makeGraph function. In the makeGraph function, we call Boca to create a plot. We then have Boca turn that plot into a vertical stacked bar graph. Once we have the vertical bar graph, we add our hover tools, which when hovering over the graph with your cursor display information about the graph. Once you have your vertical bar graph, we then add our legend, which displays more information, and then we have our boilerplate, which is our positioning, our sizing, and our labels. We then return the graph. Once the graph is returned, you can see that it displays a nice and easy to read graph on our web page, and in my case, this displays the female to male ratio in the computer science department. After generating our test pages and becoming more acquainted with the code base, we realized that Bokeh was not as easy to understand for new developers. We took the information we learned to create a wrapper class. Our wrapper class takes the Bokeh functionality and generates a graph for you. You pass it the dictionary that you generated from your queries and the number of plots you would like, as well as your positioning and layout values. The wrapper class then plots the figure for you, it adds the number of lines you would like to add, it adds the hover tools for you, and it does your positioning layout boilerplate as well as adding the legend. It then returns the graph back to the class. To show the usefulness of this wrapper class for generating line graphs, here's a graph from last year's group showing the annual tuition and fees. This graph was created similar to the test pages we show you with the individual calls to Bokeh. Using this wrapper class, we're able to generate a graph by querying the database, getting the dictionary, and then setting our values and passing it into the wrapper class. It is a much easier to read code base and is much easier to use, and as you can see, the graphs look the exact same. After creating and using the wrapper class, we then decided to add more functionality to the original Factbook in the form of a data dashboard. A data dashboard takes individual graphs and stitches them together into one easily viewable web page. This functionality is easier in Bokeh than one might think. You import your individual graphs, and using Bokeh's grid plot function, it stitches all of them together and into an individual plot, which is then returned to the web page. Thank you guys for watching our demo of Interactive Factbook 2.0, and I will now be passing it to Elizabeth Blackwell.
Thanks, Anthony. So in our testing, we wrote test cases for all of our use cases, but the ones we focused on for winter term were for the dashboard and graphs. As Anthony showed us, it is confirmed that the wrapper class for the creation of line graphs works for any displayed line graph, including those within dashboards, and thus it fully passes our tests. Unfortunately, the same cannot be said about our dashboard. It does not meet our template expectations and has not been added to the expandable menu and thus does not fully pass our tests. Below that are the use cases. For winter term, we focused on use cases 2, 3, 4, and 5, and these use cases are used in the next slide. This is our test traceability matrix. As you can see by the names of our test cases, they are fairly specific to our use cases, but some do incorporate multiple use cases. It's a little hard to talk about division of labor because we all work so closely through this process. We decided fairly early on that Anthony would focus on the back end and I would focus more on the front end, and Michael would focus on the project overall. And next term we'll probably see a division of labor closer to this, but for this term we really took our time together to learn the system and figure out what changes our client wishes to see and how best to implement those. So in conclusion, I'd like to first direct you to the image on the slide. This is the dashboard that our client provided. Now our dashboard will not look like this. Our client does not want it to, but once it meets full client specifications, it will provide all users with comprehensive knowledge of some of SOU's most important statistics. Our update to the visualization packages proves that new versions of required software will be easy to implement without changing the product. The single line wrapper class already reduces hundreds of lines of code. So essentially, we still have a lot to do next term to be where we want to by the end of this project. But what we've done here is build a solid foundation for getting there. Next term, we plan to finish the dashboard, write a wrapper class for bar graphs, implement a user feedback button, make improvements to existing graphs such as this one on the slide. Now this one is ambiguous in that it's supposed to depict average age by student level, but because it used stacked bars, what it actually depicts is cumulative age for all groups. Now, graphs such as these we would like to adjust to better depict our institutional data. We would also like to adjust the color scheme, which as you can see from this one is not necessarily ideal. We would like to make it friendlier to the eye as well as specifically to those who are colorblind. We tested for screen reader output this term, and there are changes that we intend to make to the product next term in order to improve this output. Finally, we started this term by attempting to implement the automatic database updating and improved insertion performance, but we ended up just spending an enormous amount of time learning the backend and building up a foundation in order to do these things next term. Thank you for checking out our project and our progress. We hope you'll check us out again next term. This is Elizabeth Blackwell, Anthony Ungaru, and Michael Benz signing off.